Hello everyone. Today we're looking at arc lengths and coterminals, an expansion on what we were talking about previously with degrees and radians. So, arc length. We can think of arc lengths as partial circumferences. That is to say that if this entire circle has some circumference, the arc length refers to only this portion of it. This arc length is going to be based off of the central angle and the radius, such that our arc length formula is going to be equal to the arc length, S, is equal to the radius of the circle times theta. And theta is the angle produced by this arc measured in radians. So if we have a theta in degrees, we'll need to convert our theta into radians using our radian conversion process from, what was that, Thursday. If it's already in radians, then we just need to multiply our theta by our radius, and we'll get our arc length. Now, identification. So we can describe our arcs with 2 or 3 letters. 2 letters indicates the desired arc length passes through those 2 points. So for instance, arc FE would be this segment here. It would not be the segment that runs around the outer circle, be the shortest distance between those 2 bits, those 2 points. We could also write it as FE, little curving mark on top, indicating that it's an arc. However, 3 letters indicates the desired direction of the arc. So for instance, arc, let's change the colors here. Arc FEG would be arc FE and going all the way around to G. Whereas arc FEH would be the arc that runs from F to E and then to H. All right, so let's take a look at some practice. We want to find the measure of arc EH. So arc EH, if DG is a radius of 7 meters. All right, so DG is going to be 7 meters. Well, our equation is going to be the arc length is equal to the radius, in this case 7, times our theta in radians. So we look at our arc here of HE. This is our central angle. This indicates a 90-degree angle. But 90 degrees is not what we want. We want a measurement in radians. So first things first, we're going to take our 90 degrees, and we're going to multiply that by our pi over 180 to convert to radians, which will give us pi over 2. Now that we have our pi over 2, we'll take our pi over 2, we will multiply that by our radius, in this case 7 meters, and we'll end up with 7 pi over 2, which, if we wanted to solve it out or simplify it, would be approximately equal to 11 meters. All right, second problem. We want to find the measure of arc HGF if DG is a radius of 12 meters. 12 meters, and we're trying to work with HGF. So, we know that this is 90, this is 50, so all of this in here must be 90 plus 50, which would be 140. So everything out here would be 360 minus 140, or 220 degrees. Now again, 220, that's not what we want. We don't want degrees, we want radians. So we're going to take our 220 degrees, we're going to multiply that by our pi over 180, which will give us 11 pi over 9. We're then going to take that 11 pi over 9. We're going to multiply that by our radius of 12 meters, which will give us 132 pi over 9. Or if we want to simplify that or approximate that, it would give us approximately 46 meters. And that's really it about arc lengths. We use our equation, identify what we have, and then use our equation to find out what we're missing. Coterminal angles. So coterminal angles are angles in a standard position, the angles with the initial side on the positive x-axis, that have a common terminal side, a common ending side. For example, 45 degrees here, negative 315, and 405 all end at this coterminal side that extends out at the 45-degree angle. How do we find coterminal angles? Well, that's actually a fairly simple process. All we're going to do to find coterminal angles is we're going to take whatever angle we have, and for degrees, we're going to add or subtract 360 to the initial angle. So for instance, if we had, for instance, our 45 degrees, to find coterminal angles for it, we would take 45 degrees and add 360 to it. And that would give us our 405 degrees. To find the coterminal on the opposite end, we'd take our 45 degrees, we'd subtract 360 degrees from it, and that would give us our negative 315 degrees. For radians, we'll do something similar. For radians, we'll add or subtract 2 pi, or a fraction that is equivalent to 2 pi. So let's say, for instance, I had a measurement of pi over 7. I want to find 2 coterminal angles for this. Well, I'd take my pi over 7, and I'd add to it 2 pi. But 2 pi and pi over 7 don't have the same denominator. So I need to convert 2 pi into an appropriate fraction that has a 7 in the denominator. Going back to middle school, we should know that we can convert this, that 2, into a 14 over 7. So pi over 7 plus 14 pi over 7 gives us 15 pi over 7. That would be one coterminal angle. To find the other coterminal angle, we'll take our pi over 7, and we'll subtract our 14 pi over 7, which will give us negative 13 pi over 7. That's it. Now, unless otherwise stated, and this is the big important thing, unless otherwise stated, please, please, please only look for coterminals that are one shift away. While it is true that you could, for instance, add 720 to an angle and find a coterminal angle, for any sort of multiple choice or fill in the blanks that you might have on today's assignment or future assignments, we're looking for one shift away unless otherwise noted. All right, let's take a look at some practice problem. So find the coterminal angles for the following. 7 pi over 4 and 219 degrees. So 7 pi over 4, we're going to start off with our 7 pi over 4. We're going to add 2 pi to it. We're going to take our 7 pi over 4 and subtract 2 pi from it. But our 2 pi and our 7 pi over 4 are not in the same denominator. So we'll have to transform our 2 pi's into something that has a denominator of 4. Well, real quick, that would change our 2 pi's into 8 pi's over 4. Such that one coterminal angle would be 15 pi over 4, while the other one would be negative pi over 4. Meanwhile, for our degree measurement, we have our 219 degrees. We're going to add 360 degrees to it, and that'll give us 579 degrees. We're going to take our 219 degrees, we're going to subtract 360 degrees from it, and that'll give us 149 degrees as our second coterminal angle. And that's it. So in the folder for today, you'll find a little assignment for it. Please, please, please complete it. Please, please, please ask questions if you're getting stuck on anything. Take care. We'll touch base tomorrow.